Okay, so we're doing the rest of 3-4 today and the beginning of 3-5. So if you're gone on retreat or missing for whatever reason, this is what I want you to watch to get caught up on the notes. So we're starting at the beginning of 3-4. And it says, write as a single logarithm. What's happening here is we're going to do what we call condense it. We're going to condense, or we're going to make these smaller. So I have it all spread out into multiple like logs right now, and we're going to condense it down to just be one single log. I think you might have done this already, so let's see what we remember. If I have log base x minus log of y, what happens? How can I combine those two logs into one when it's already being separated by a minus? Divide. Very good. So whenever you see a subtraction, we're going to treat that as a division sign. So I'm going to write a little key at the top. My iPad will work with me. So anytime you see a subtraction, that's the same thing as a division. So like in this example, I've got log of x minus log of y. That becomes log of x divided by y. And it just says write as a single log, nothing else. That's as good as it gets. All right, the next one, I've got an addition sign in here. What do we think it means when we have the addition sign? Multiply. Good. So I'm going to write in my little key again. I'm going to say add equals multiply. And then my pencil works. Add equals multiply. So subtraction equals division, add equals multiply. And then I've got one other thing right here. Do you remember what happens with that 2? When it's a coefficient in front of the log, where does it, an exponent. Very good, Camille. It's an exponent, so it becomes x squared. So anytime you have, I'll just write a coefficient, it becomes an exponent. And I'm going to write this in a couple steps just because the longer I write out, the more hopefully you understand. You can rewrite this as log x squared plus log y. And then we're going to combine it with multiplication. So we'll say log x squared y. And that's my best answer. All right, let's keep moving. The next one says 1/3 log z plus 2/3 log w. Let's make our exponents, our coefficients go as exponents. So z to the 1/3 plus log w to the 2/3. Do you remember what it means when I've got a fraction as a radical? Or sorry, I just messed that up. A fraction as an exponent is a radical. So I want that to be, instead of log z to the 1/3, I want it to be log cube root of z plus log. We know that the 3 on the bottom makes it a cube root. What does the 2 on top do? Exponent. Good. So it'll be w squared inside that cube root. It's okay to do this because now when I combine them using multiplication, since they were being separated by an addition, I'm going to make them both under the same cube root. So I'll make it go log of cube root of z w squared. Since they were both under cube root, I can combine them under the same cube root. If I'm not recording, I'm going to figure out. Okay, yeah. It's so annoying to like have to redo something that I've already done. So when I teach this 3 times already, if I have to go back and do it another time, it just makes me so mad. So, all right, keep going. Next one, same idea. This one we're going to simplify though, because we actually have numbers here. So I have log of 16 raised to the 1/2 minus log of 8 raised to the 2/3. 16 to the 1/2 is the same thing as what? 4, because 1/2 is square root of 16 is 4. So I get to rewrite that as log of 4. And then 8 to the 2/3, I'm not going to be as good at that one. Let's write that one off to the side. It's going to be cube root of 8 squared. You can think of it 2 different ways. So how I thought of it yesterday was like, okay, well, I can do 8 squared. So that's cube root of 64. And then I can ask myself, okay, what cubes to be 64? That's just going to be 4. What someone did in my other class is we were like, okay, let's do the cube root of 8, which is 2. And then we're going to square that, which is still 4. So you can separate it that way too. If you want to do the cube root of 8 and then square that, if those numbers are smaller and make more sense to you, that's okay. But that's still going to be log of 4. So now I've got log of 4 minus log of 4. How do I combine those to be one log? Divide. So I've got log. That's messy. Let's try that again. Log of 4 divided by 4. And can you divide 4 and 4? Get log of 1.
Do you have to put the 1 or do you just put the 1?
We have to put the 1. It's not assumed anything. Actually, this we can simplify even farther if we want to. So log of 1 is just log base 10 of 1. You set that equal to x and then you do your log roll. 10 to what power gives me 1? 0. So log of 1 is just 0. So you can write that as a shortcut if you want to. If you want to go all the way down. Anthony's back. All right, the next one we have to simplify again too. Thank you. So I'm going to do my exponents first. I've got ln of 2 to the 3rd plus ln 36 raised to the 1/2. 2 to the 3rd is 8. That one's easy. 36 to the 1/2. That's a square root. So that's going to be 6. When we combine these two separate logs, because we're adding them, we multiply them together. And I want you to physically multiply 8 and 6 together, which is 48. And I actually think the last one's the easy one because it's just variable. So get your exponents throughout, do your dividing, and simplify. I'm going to make that go to the 4. Log x to the 4th, y to the 4th, minus log x to the 3rd. Minus means that we're dividing, so I've got log x to the 4th, y to the 4th, over x to the 3rd. Oh, and we cannot forget our exponent rules. If you've got an x to the 4th on top and an x to the 3rd on the bottom, those cancel out, and we're just left with x to the 1st on top, which means I have no more bottom. I just have x, y to the 4th. Log of x times y to the 4th.
So like when it says just write a single logarithm, you don't have to solve it, just multiply by it.
Just simplify it down, get it down to 1 log. So that's what we call condensing, making it smaller. What we're about to do is the opposite. Now we're going to expand it out. So I'm going to take a single log and I'm going to separate it to as big as we can. We're expanding the following. The same rules are also there. So if you see a subtraction, or if we see, this time we're going backwards. If we see a division, we're going to separate it with the subtraction. If we see a multiplication, we're going to separate it with an addition. If we see an exponent, we're going to make it a coefficient. Let me walk you through a couple and then I'll have you try some on your own. So ln of x times y, the multiplication means that I want to separate it with a plus ln of x plus ln y. Let's just do the one underneath it since I like physically see it right here. Let's look at letter C. Log of the 5th root, or radical of 5 of x divided by y, what would that be as an exponent? 1/5. So I've got log of x over y raised to the 1/5. I'm going to put the 1/5 out front here. And when I separate them, it's division, so I'm going to separate them with a what? Subtraction? Is that what you said? Oh, minus. Yeah, that's the same thing. I feel like in this room, this like radiator is like not that loud, but it's loud enough that I just like can't hear you guys sometimes. So I have to like make it up. And I'll be like, oh yeah, I think that's what they said. But then I'm afraid I'm like, yeah. And then you're like, that's not at all what I said. So I've got 1/5 log x. I also want the 1/5 to go with the y. So I'm going to say minus 1/5 log y. That shows that that 5th root goes over both the x and the y. I'm sorry to jump around, but let's go do D really quick. How is that different than what I just did in C?
The y.
Good. The radical is only on top. The y is not involved with that radical at all. So the 1/4 only goes with the log of x. It does not also go with log y. So when I write this out, I get 1/4 log x minus log y. I separate it with a subtraction because it was division, and the exponent, essentially, the radical only goes with the first one. Do you see how that's different than what we did before? So you need to be intentional. Do you carry that like exponent through, or do we leave it alone? All right. Can you try B, E, and F really quick? And I'll jump in with you. All right, I thought B was pretty self-explanatory. You guys all get 3 log x minus 4 log y. Perfect. On these other ones, on number E, I'm gonna actually have us like push it a little bit farther. So I do have a multiplication here between the 100 and the x squared. So I'm gonna split it to be log of 100 plus log of x squared. And we physically see that there's an exponent with x squared, so we're gonna make that 2 log x. I want us though, can you make 100 be something squared or something to a certain power? Yeah, that's the same thing as 10 squared, right? So I can think of it as log of 10 squared. So I want the 2 in front of the log of 10 as well as the 2 in front of the log of x. So I want us to end with 2 log 10 plus 2 log x.
Does that matter in the test? Like log 100.
I want you to recognize that it's a perfect square and that we can separate it like that. Because we have a number in the next one, but can you separate that one like that? No. So it only will happen in like very few circumstances, even if at all, because the first 4 examples I gave you were all variables. But I want you to kind of just be on the lookout. Every time we see like a 10, I want us to do something with that. So ln of 30 e to the third. So I can make that ln of 30 plus ln of e to the third. And then carry your 3 in front of just the ln e. And I would love for us to get to the point where when we see ln of e, we can simplify that down because ln is the same thing as log base e of e. If that's equal to x, e raised to the x equals e. What should x equal? 1, 1. If you have ln of e, that's the same thing as log of e, log base e of e. I've got a lot of e's going on here. And when I go to do my log roll, I do e raised to the x equals e. So I'm asking myself, e to what power gives you e, gives you itself? It's just 1. So I can leave this as ln 30 plus 3 times 1, which is just 3. We're not spending a ton of time in this unit. If we spent more time, I'd give you more of these kind of like hidden LNs and for us to like simplify and solve all the way down. But I need us to just kind of practice these concepts of expanding, condensing, evaluating like we did the other day. And so the simplifying is not as big of a deal just because we're spending such a short amount of time on it. All right, we did number 3 the other day in class. That was just calculator stuff. Was everybody okay with that? It's easy, nice little part to end the day the other day. Mm-hmm. I've got 2 little word problems, and these are just kind of plug and chug word problems. We just got to figure out where we're plugging and how we're chugging. So 4a says the relationship between intensity of light and lumens at a depth of x feet in Lake Superior is given by this equation. Log of I divided by 12 equals negative 0.0125x. What's the intensity at a depth of 10 feet? Where do we think 10 is going to go? X. It says depth of x feet. We have a depth of 10, so we're going to plug x in, or 10 in for x, and we're going to solve from there. So I've got log of I over 12 equals negative 0.0125 times 10. Log of I over 12 equals negative 0.125. Just move the decimal when you multiply by 10. And the reason this is in this section, or it's after at least 3.3, is because we had to remember that log base 10 was there if we didn't have a base, and we're going to log roll this. So I'm going to do 10 raised to the negative 0.125 power equals I over 12. Say that one more time. If there's no base with your log, we assume it's a 10. So I'm going to get my calculator out so I can actually calculate what this is. So I've got 10 raised to the negative 0.125. So I get essentially 0.75. It's basically 0.75 equals I over 12. And I'm going to multiply that by 12. And I get 8.9987. That's basically 9. My illumin, or my lumens, my intensity is 9. Anybody questions on that? All right, the next problem is another plug and chug. It gave us an equation, and it says A is the amplitude, T is the period in seconds, B accounts for the weakening of the seismic wave, and then it says compute the earthquake magnitude if I give you A, T, and B. So we're just plugging A and T and B into our equation, and we're going to solve for that. I'll do letter A, and then I'll have you do letter B. So R equals, we don't have anything for R, that's what we want, equals log of A, which is 250, divided by T, which is 2, and then plus B, which is 4.25. I always talk about how you guys have fancy calculators. You can probably just type that all the way in if you want. I'm always careful because I'm afraid of losing a parentheses. From having old calculators, I've had to be way more careful. So I'm going to do it piece by piece. I'm going to do 250 divided by 2. And then I'm going to do log of that. Remember, log without any base is just the one that you physically see on your calculator, log of 125. And then I'm going to say plus 4.25. So I got a 6.35, we'll say, on the Richter scale. You do letter B. Oh, sorry, 6.35. I got, for letter B, I got 5.38. Is that what you guys got? We're going to keep rolling. Oh, maybe not.
Is Dominic Siegel in the room?
Yes, he is.
Please send him to the front office. Thank you.
Bye. Is it like a parade of football coaches this week? Bye, Dom. He did not seem too thrilled to leave. Anthony, who'd you talk to? Wabash. Any interest in that? Okay, that's all right.
I don't know.
I was gonna say, do you think you want to play in college?
Probably.
I've had a kid called out every class period for football this week, so. I mean, not every class period, but at least like 2 a day.
Who's that?
Who?
Yeah.
I have Danny O'Neill in class. I had him get called out. Parker got called out the other day. You and Dom today. I think somebody else maybe. Well, that's fun for you guys. All right, let's keep moving. What I was gonna say is we're gonna keep rolling because I'd rather have extra time at the end of class for you to like actually do something with it. We have finished 3-4, so I do want that due when I see you next class. So 3-4, and we'll have time to work on that today. I want to get all the way to I on number 3-5, and some of these will go pretty quickly. We're moving a lot faster than yesterday just because there's a lot less of us and a lot less side conversations because I think you're still asleep. So that's okay. We're getting through our stuff. These are all solved no calculator. So I put my calculator away. And they're all in exponential form. We'll do logs next time I see you. But these are all in exponential form, and we're going to just kind of solve and simplify. Some of them are as simple as just looking at what I see. So I've got 2 raised to some power equals 8. 2 to what power equals 8? 3. Perfect. That's it. No work. X equals 3. Let's draw box. Okay. Letter B. Now we've got to do a little extra step. We have to get rid of that 3. It's not 3.4 raised to the x. It's 3 times 4 to the x. So let's divide by 3 from everything. 4 to the x equals 48 divided by 3 is 16. Oh, cool. 4 to what power is 16? 2. Yeah, it does look like 3.4. Make sure it's very clear on the test please. Okay, see where it gets a little bit of a curveball. The reason it's a curveball is because I don't easily know what 4 to some power is 8. However, can you write 4? Hi.
What's that?
It's in my calculator.
How rude, right?
Yeah,
At least he brought it back, right?
2 days late.
2 days late.
Sorry.
Bye. Can we write 4 as 2 to some power? Yeah, 2 to the second, right, is the same thing as 4. What about 8? 2 to the third. Good. We want the bases to be the same, so we want them both to have a base of 2, because if their bases are equal, then their exponents will have to be equal to each other. I left it in parentheses though, because I wanted to remind you that now I'm doing power of a power. So when I combine my 2 and my x, am I adding or multiplying them? Multiplying. Power of power is multiplying. That's why I ask, because sometimes we forget. 2x equals 3, 2 to the 2x equals 2 to the third. So since the 2, they're both being raised, sorry, both of them have a base of 2, then their exponents must be equal to each other. So 2x equals 3. Divide by 2. X equals 3 halves.
Is it so like exponents drop out?
The bases drop out. You let the exponents just equal each
Oh,
other. Because they both have a base of 2, it just like doesn't matter. So if they don't already have the same base, so you can't make like, if it's not as easy as like, oh, 2 to some power is 8 and 4 to some power is 16, you can make them have the same base. So that's what we're gonna do for the next couple. So let's divide by 3. I've got 4 raised to the 2x equals 96 divided by 3 is 32. I already know that 4 to some power can't equal 32. 32 cannot be written as 4 to some power, but they both can be written with a base of 2. Yep. We already know that 4 is 2 squared, so I'm gonna write 2 squared. I was really intentional to keep that 2x on the outside so I didn't lose any 2's. I don't have a 2 going away. And then 32, do you know what 2 to what power is 32? 5. Sometimes I even have to write it out. I'm like, okay, 2 times 2 is 4, times another 2 is 8, times and then I count them up at the end. So whatever little method you use. This is helpful because now I've got 2 raised to the 4x equals 2 to the 5th. Again, they both have base 2, so the bases go away, and I can set 4x equal to 5, and then I can solve. Divide by 4, x equals 5. All right, you ready for the next one? And I'm gonna have you try a couple on your own, and then I'll come back. What should I do first here? Divide by 2. So I've got 5 raised to the x over 3 equals 125. I can't write 5 as a number to another power to get to 5, but can I write 125 as 5 to some power?
Yeah.
5 to the
Third.
third. Mm-hmm. So now what? Good. X over 3 equals 3. The 5's canceled out because the bases were the same. You just said the exponents equal to each other now. Multiply by 3 to get x by itself. X equals 9. Can you take a couple minutes and try F and G, and then I'll do them with you to confirm that they're good? Try F and G on your own. take one more minute and I'll join you on that one that I asked you to do. All right, let's look at letter F. I know you might not be done, but let's look at letter F. We're going to divide by 2 from both sides. 9 raised to the x plus 3 equals 27. I can't write 27 as 9 to a power, but I can write both of them as 3 to a power. So 3 squared is 9. So that's x plus 3. And then 27 is 3 to the third. I'm going to distribute that 2 to every part, so it becomes 2x plus 6 equals 3 to the third, so that I'm ready to go when I set them equal to each other. Bases cancel, 2x plus 6 equals 3. Minus 6 from both sides, 2x equals negative 3. Divide by 2, x equals negative 3 halves. That's okay. Anybody questions on F? Shall we go look at G? No? Okay, we're going to divide by 36, and I know our first instinct is to go put that in the calculator and get a decimal out. I want you to fight that urge, and I want you to just do that in our head. Let's think about what can we cancel with 9 and 36? They both have a factor of 9, so we can cancel that out and get 1 and 4. Oh, now that I have 1 and 4, I can make that be in terms of 1/2, right? 1/4 is the same thing as 1/2 to what power? 2. 1/2 squared. 1 squared is 1, 2 squared is 4, so 1/2 is the same thing as, or 1/4, excuse me, is the same thing as 1/2 squared. And then I don't have to change anything on my left side. I can just make it as 1/2 raised to the x over 4. Now my bases are the same, so I can cross them out. And I set my exponents equal. X over 4 equals 2. Multiply by 2, x equals 8. All right, we got 2 more I want to do. Do you want to try them on your own, or you want me to go through them with you? Try them on your own. Okay, take a couple minutes. Do you have a question?
For letter G,
Yeah.
if you have the 1/2 to the x over 4, or x over 4 equals 1/4, if you can just make the 1/2 2 and then 1/4 of 4, and then just solve it that way, it'd be 2 to the x over 4 equals 4.
Like this. And then 4 becomes 2 squared.
Yeah.
Yeah, because then I still have those equal to each other. I cannot promise that works all the time. Let me explore that a little bit more, but it definitely works here. I think it works because technically if we make this a 2, then this would be like negative x divided by 4 because we like flipped it as a fraction.
Yeah.
But I did the same thing on the other one. I make that like a -1 or make that negative. So it'll be negative equals a negative, which is the same thing as a 2 positive. So I think that works all the time. Yeah. If you flip both of them. All right, take another minute or two, try I and H on your own, and then we'll go over them together, and then that'll be today.
You have a negative exponent.
Yes. just gonna do them while you're working so you can check the answers on the board, but I'm not gonna talk through it this time. So you can just kind of look as you want to. All right, my answers for H and I are up on the board. Anyone get one of them right? Anyone get both of them right? Three still high five, got both of them right. If you didn't get one of them right, do you want me to talk about why, or are you like, oh, I see exactly what I did? Which one was the easier one?
First one.
Oh, you thought I was easier, Curtis? You thought H was easier, Noah?
Say H.
H was easier. The one thing I have to say about H is that like what I think of is like I kind of stop here and I'm like, okay, what can I do to 1/3 to make it equal 9? I know that I can flip it to make it not be in the denominator anymore, and then I know 3 squared is 9, so I just went immediately to -2. I kind of was like, what can I do to 1/3 to get to 9? If you want to manipulate them a little bit more to get the same base, the first thing I thought of was, okay, well, if I make 1/3 just a normal 3, I can make that 3 to the -x, and then 9 will become 3 squared. Or you can even keep it as 1/3 over x, and if you make 9 into 1/3 to some power, then I would have to think through that and get to -2, and at the end of the day, I still have them equal to each other. So lots of different ways to get to the same spot. Whatever kind of works best in your brain is what I want you to use. All right, that's it for our notes today. We're going to do a little review. We're going to do our quiz, and then I want to get into a little bit more of this on Friday because I want to leave most of Monday for 3-6, so I can have a full day of review and then a test. But we'll just kind of see where we're at
That's Friday.
next Friday. So I'm gonna stop this recording.